Hello, Lena. This is Miss Tracy. Let's look at lesson 116-117. So Roger rolls a pair of dice. What's the probability in 2 rolls he'll get a total of 7 on the first roll and greater than 9 on the second roll? So there's 2 dice, right? We want the probability that we'll get a 7 on the first roll and greater than 9 on the second roll. So to get a 7 with 2 dice, we have to have a 6 and a 1, 5 and a 2, 4 and a 3, 3 and a 4, 2 and a 5, 1 and a 6. That's 6 rolls out of a total of 36 possible outcomes, because 6 times 6 is 36. That reduces to 1 over 6 for the first outcome. For greater than 9, with 2 dice, let's start with our highest, which would be 6. The first number greater than 9 is 10. So we want to get 10, 11, or 12. So that would be 4 here. We can go up. 6 and a 5 would be 11. And a 6 and a 6 would be 12. All right, so the second dice has already rolled a 6. The only other possible outcome is for the other dice to be a 6. So that one stops that. The next number is 5. And we can roll a 5 to get 10. Or we can also roll a 6 to get 11. That's as much as we can get there. The next number that's possible is 4. And the only thing we can roll with a 4 is a 6 to get 10. We can't go any lower than 6 because then we would have 9. And then it would be equal to 9, not greater than 9. So 1, 2, 3, 4, 5, 6. That equals 6 out of 36 chances, which reduces to 1 over 6. So we multiply that. We get 1 over 36 is our probability of getting that. 1 out of 36 rolls. All right, so let's look at the next one, the chair question. So it's really straightforward. You have 9 students. There's 5 chairs. 1, 2, 3, 4, 5. So you pick one of the 9 students for the first chair, one of the remaining 8 for the second, one of the remaining 7 for the third, one of the remaining 6 for the fourth, and one of the remaining 5 for the fifth. And we just multiply those together. And we multiply those together, we get 15,120 when we just multiply. That's what that equals. So pretty straightforward problem. And yes, you can set it up as 9 factorial over 4 factorial. That's just going to equal 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. That just cancels, and that becomes this number, which is this right here, over 1. Same answer. All right, let's look at the telephone digits question. So this one is a little bit different because we have 10 digits, right? 7-digit phone number, 1, 2, 3, 4, 5, 6, 7. But in the first 3 digits, we can't use 0. So that means instead of having 10 digits available, we only have 9 digits, and they can be repeated. So 9 and 9 here. But now in the next 4, we can use all 10 digits however we want to. And because we can repeat them, we don't drop any. So when we do this multiplication, we get 9 times 9 times 9 is 729. And then this is times 10,000. So we just add 4 zeros to the end. 1, 2, 3, 4. And that gives us 7,290,000 is the answer for this problem, because we just multiplied everything straight across. And that's our answer. All right, so let's look at graphing now. So these are pretty straightforward. Our first problem says that X is a member of the set of real integers. We're looking at integers. The Z means integers, such that X plus 3 is greater than 5. So all we have to do is say X plus 3 greater than 5 minus 3 from both sides. X is greater than 2, and we're only doing integers because of the Z right here. So then you would graph it to look like, see if it'll let me drag it. It won't let me drag it. So you would just be graphing from the 3, 4, 5, 6, 7, and so on. You'll just be graphing on the integer with a dot like that. Because x is greater than 2, 3 is the next integer that's greater than 2. All right, that is pretty straightforward. So I'm going to let you do the next one by yourself. And then we'll look at graphing this quadratic inequality. So x is a set of all right, so this is real numbers, so we will be using a line here, such that x squared is greater than or equal to negative 4x minus 3. So all we have to really do is set this up so that we can set it equal to 0 and factor it. So x squared, I'm going to add 4x to both sides. I'm going to add 3 to both sides. So that's going to be, let me move this down a little bit, x squared plus 4x plus 3 is greater than or equal to 0. All right, so now we can factor this. So this is going to be x plus 3 times x plus 1 is greater than or equal to 0. So now what we're going to do, in order for this to be true, it has to be equal to 0, but we also have to understand the properties of being greater than 0. So what that means is we're going to split it up into two different parts. The first part is where x plus 3 or x plus 1 is equal to 0. So we would just say x plus 3 is equal to 0 and x plus 1 is equal to 0. So x is going to be equal to negative 3 and x is going to be equal to negative 1. So those are our first two true statements that we have to remember. Now we're going to take the greater than part. So in order for it to be greater than, it has to be a positive number. In order to get a positive number, we have to multiply a positive times a positive or a negative times a negative, right? So those are our criteria. So we're going to set each one of those to those conditions. So to be greater than 0, so greater than 0 here and greater than 0 here. That's what we're going to do. A positive number is greater than 0. So x plus 3 is greater than 0 and x plus 1 is greater than 0. So we subtract, and x is greater than negative 3 and x is greater than negative 1. Those are our two things we're going to test. On this side, where we have negative times negative would give us a positive number, which will be greater than 0. We're going to set these because a negative number by default is less than 0. X plus 3 has to be less than 0 for it to be this negative number. And x plus 1 has to be less than 0 for it to be this negative number, right? So we'll do the same thing. We'll subtract. We get x is less than negative 3 and x is less than negative 1. Now we will test those and see which ones go with the above up here. So we're going to just take that original equation, which is x squared plus 4x plus 3, right? So x squared plus 4x plus 3 greater than or equal to 0. That's what we're testing here. So let's look at it. Let's take an integer greater than negative 3. That'd be negative 2. So negative 2 plus 4 times negative 2 plus 3. So that would be positive 4 minus 8 plus 3. That'd be negative 4 plus 3. That is not true. That'd be negative 1 is not greater than. So that one can't be true. So let's try the next one. Greater than negative 1. Well, that'd be 0. So that'd be 0 plus 0 plus 3. Positive 3 is greater than or equal to 0. It's greater than 0. So this one is true. So let's look at less than negative 3. Well, that'd be negative 4. So negative 4 squared plus 4 times negative 4 plus 3, is it greater than or equal to 0? 16 minus 16 plus 3, that becomes a 0. 16 minus 16 is 0. 3 is greater than or equal to. So this one is true, right? So let's do it for the last one. Make sure. So x is less than negative 1. Less than negative 1 would be negative 2. Well, we already tested negative 2 over here with x is greater than negative 3, and it wasn't true. So that one's not true either. So what we put here, x is greater than or equal to negative 1. Greater than or equal to negative 1, because we combined this one and this one. And we're going to combine this one and this one because x is both equal to and less than negative 3. These are our true statements, this one and this one. So we combined the negative 1 statements and we combined the negative 3 statements because they have the same integer value. So then we would graph it where we would have, you would find negative 1 and you would find negative 3. And then you would, because it's greater than or equal to, you would circle it, fill it in to get the equal to, and you would go greater than. Then you'd find your negative 3, circle it, fill it in to get the equal to, and go less than. And that's how you would graph that. And your little negative 2 would be sitting right here in the middle by itself, not doing anything because it can't be negative 2. All right, so let's look at the next one. Let's clear the page. Actually, the next one is very much like this one. So I'm going to let you do that one on your own. Number 9. Here we have a conjunction, or it's not a conjunction, it's linear inequalities. So basically what you have is y, let me go back to my other color pen, y is greater than x plus 3, and y is less than negative x. So let's write that so that it makes more sense for us. Y is greater than, there's that invisible one right here. We turn it into a fraction so we can see our slope. Same thing here. Y, here's our invisible one. Let's turn it into a fraction so we can see our slope. And there's no b value over here, so we just add 0. So that becomes our b value. So then when we graph our chart, this is what we end up with. Let me go down here to this right here. So our lines are, let me write this one in blue. Y is greater than 1 over 1 x plus 3. And the other line was y is less than negative 1 over 1 x plus 0. So here's our graph. Okay, so I'm going to do the blue in blue. Notice the inequality is greater than. There is no equal to underneath here. So if there's no equal to, we can't include the line as part of our answer. So it's going to be a dotted line to just show where that boundary lives. So we're going to start at the positive 3 right here, and we're going to use our slope to graph. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And then I'm going to use that same slope to just come straight down and create the boundary of points that I'm looking for. And then what I'll do usually is go in between just to make it more defined and easier for me to do. All right, so greater than means that we're going to do the points that are above. So the points that are greater than this line or this boundary are the ones on top. So we're going to fill in the section above that's on the graph, just like that. All right, so that would include all of those points. All right, now let's do the other line. The other line says y is less than negative 1, 0. We don't really care about this until after we get the line graphed. The only thing we note is that there is no equal to. So again, this is going to be a dotted line because the line is not part of the answer. It's just telling us in reference to that boundary line what points we want. So this is crossing at the 0. So we start at the 0 and we go down 1 over 1, down 1 over 1, down 1 over 1. So now we kind of see where that line lives. We see the slope and it's a dotted line. So we just fill in the little area. We keep going backwards. So there's our line, right? So let me get my highlighter. So this says y is less than this line or this boundary. So that means we're going to get the points that are below. So the points that are below that are also already shaded from the other line is going to be these points right here. So the points that are included, because the other section here, these are also less than this line, but the blue is the part that we're looking for. We're looking for the ones that correspond to both of these lines. And the ones that correspond to both of these lines are in this section right here. That is where the two things would overlap. So that is where you would highlight or draw your yellow line just to indicate that this is the section that you're looking for. All right, let's clear this for future pages, and we'll clear this. And we'll move on to number 10. Number 10 says that there were 16 nickels, dimes, and quarters. So that is our first statement. There are not nickels, dimes, and quarters that equal the quantity of 16. Okay. Their total value was $1.50. So that means 5 times the nickels plus 10 times the dimes plus 25 times the quarters was equal to $1.50. $1.50. How many of each kind were there if there were 3 times as many dimes as quarters? So the number of dimes is equal to 3 times the number of quarters. Now we have a substitution value that will help us eliminate one of these variables. So I'm going to put that into the first statement, and I get n plus 3q plus q is equal to 16. Well, I can really quickly rewrite that as n plus 4q is equal to 16, right? Because I subbed this in right here for d. Now I'm going to do the same thing in this statement. So 5 times n plus 10 times d, which is 3q, plus 25q is equal to 150. So then that would be 5n plus 30q plus 25q is equal to 150, which would be 5n plus 55q is equal to 150. Because I sub 3qn for the d here. Right? Okay. Now, I am going to, there's a couple ways you could do this. You could multiply this so that you have by -5 so that you could have this, or you could create another substitution value, which I think is what I'm going to do. I'm going to subtract 4q from both sides. So let me move this down. And that's going to give me n is equal to 16 minus 4q. And that is what I'm going to sub in for n right here. So I'm going to say 5 times 16 minus 4q plus 55q is equal to 150. So 5 times 16 is 80 minus 20q plus 55q is equal to 150. All right, so if I subtract 80 from both sides, and then I combine these two terms, what I get is 35q is equal to 70. If I divide both sides by 35, q is equal to 2. So now I have a value for q, and that's going to be 2. I'm going to write that right above the q. All right, so if I have the value for q, then I can also say 3 times 2 equals 6. So D is equal to 6. So I can put that right here. And that's going to help me find out what n is. N plus 6 plus 2 is equal to 16. So if I subtract 6, or if I take 6 and 2 to add it together and subtract 8 from both sides, n plus 8 is equal to 16 minus 8 from both sides. N is equal to 8. So now I have the value for D and N and Q. And there's, like I said, a couple of ways you could do it. You could either do substitution, which is what I did. I found the value of N and substituted it in. Or I could have taken this value and multiplied it times a -5, and I would have gotten to the same thing. So either way would have worked. That is number 10. Let's look at number 11. Kenneth and David rebelled at paying $4,320 because this was a markup of 80% of the selling price. So we know the the purchase price plus the markup, is equal to the selling price. And we know in this case that the markup is equal to 80% of the selling price. And the selling price was $43.20. So I'm going to substitute in $43.20 for the S here. All right, so markup is equal to, and I'm going to change this to a decimal, 0.8 times 43.20. Because that's these two things combined. So I'm going to put that back into my original problem. The purchase price plus the markup, which is this, 0.8 times 43.20, is equal to the selling price, which is 43.20. Now I'm going to do the calculations. So 0.8 times 4320 is 3456. So the purchase price plus 3456 is equal to 43.20. So if I subtract 3456 from both sides, that should give me the purchase price, and 43.20 minus 3456 is $8.64. I think I'd rebel at that price too if the original cost was only $864 and they want to sell it for $4,000. That's a heck of a markup. So this would be your answer, $8.64. And then the store markup was $34.56. So the question asks for that also. All right, so here we have just some calculator problems. They're just some logarithm problems disguised as a pH solution problem. So we have pH is equal to the negative log of H positive. We can rewrite that as H positive is equal to E to the negative pH. All right, so if the pH is a negative, or is 5.34, so our first option is 5.34, we would write H plus is equal to E to the negative 5.34. And if we put negative 5.34 in our calculator and then press the 10x key, let's see what we get. We get 5.34, make it negative, and then the 10x key, we get this number, right? So let me write that down. That's 1, 2, 3, 5 zeros. So 1, 2, 3, 4, 5, 4, 5, 7. The next number is a 0, so I'm going to stop there. We don't want to write that number. We want to write it shorter, so we do scientific notation. So 4.57 times 10, 1, 2, 3, 4, 5, 6. Negative 6 because we went backwards. So that would be the answer for the first one. The second one, B, is going to be, let's see, what is the second one? 0.00263, right? So we write it as H plus is equal to E to the negative 0.00263. So we take negative 0.00263 and we put our 10x key, right, in the calculator. 0.00263 negative, hit the 10x key, and we get almost 1. We get 0.9939. So what I'm going to do is I'm going to round this up to 3 digits, because if I rounded it up to 2 digits, it would be 0.99. And that really doesn't express all of the rest of this back here, right? We need to include all the rest of this. So I'm going to express it as a 3-digit number because that's what the book tells me to do. Now, if you put in 0.99 or if you put in 1, I would probably mark it correct because you wouldn't know how the book wants you to format it. But generally speaking, if you have a bunch of 9s and then a different digit here and then some more numbers, stop at the end here. Stop at this digit here. See if you can round it up if you can include it. So this answer is going to be 0.994. And the reason we didn't use scientific notation and make this 9.9, like you could write it as 9.94 times 10 to the negative 1. Why would you write all of that when you just have to write 4 digits? Remember, mathematicians are lazy. So if we can write this instead of writing scientific notation, the whole point of scientific notation is to write something bigger, smaller. So we would not write something smaller, bigger to put it in scientific notation. That's the logic anyway. I hope that makes sense. All right, so let's look at the next one. The triangles. Let's clear this. And I'm going to rewrite these such that I can see both triangles independently. So I'm going to draw them out. Here's one triangle. We have 6, we have B, and we have A. The other triangle, I'm going to make it a little bit bigger. And this is 6 plus 3 is going to be 9. This is 7, and this is A plus C, whatever that is. So I'm going to use scale factor to find out 6 and 9. So let's call this the small, and let's call this the large. So I'm going to take 6 times some scale factor. Actually, let's write it out better. I'm going to take the small triangle times some scale factor, and that's going to give me the dimension for the large triangle, right? So we've got 6 on the small triangle times some scale factor. That gives me 9 on the large one. And I picked the 2 that have numerical dimensions so that I can do some math. So when I divide both sides by 6, I get that the scale factor is equal to 9 over 6, which is equal to 3 over 2 when I reduce the fraction. So this is my scale factor. The scale factor is 3 over 2. So I'm going to use that scale factor to solve for B. So on the small times 3 over 2, that is going to be equal to the large. So in this case, I'm going to do B and 7. So B times 3 over 2 is equal to 7. Well, to get rid of a fraction times a variable, we multiply by the reciprocal, right? But we got to do that on both sides. So 2's would cancel, 3's would cancel. 2 times 3 would, and 3 times 2 would be 6 over 6. So it'd be 1 anyway. So you have b is equal to 14 over 3. That is the value of b. So I am going to erase this, and I'm going to put 14 over 3 right here. I don't know. All right, there it goes. I don't know why it blinks like that on me. So now that I have figured out that this is 14 over 3 and this is 6, I can actually use Pythagoras' theorem to find the value of a. So that's what I'm going to do. I'm going to come down here and I'm going to say a squared plus, or actually, yeah, I'm doing it right. Hello. 14 over 3 squared is equal to 6 squared. So a squared plus, let's do 14 times 14 because I can't do that in my head. 14 squared is 196 over 9 is equal to 36. All right, so I'm going to have to subtract this from both sides. So I'm going to take that 36 and I'm going to put it over 9. 36 times 9, that's going to be 324. So this would become 324 over 9, right? So now I'm going to subtract 196 over 9 from both sides. And I get that a squared is equal to, I don't know why it keeps jumping on me like that. 324 minus 196 is 128. So 128 over 9. So now I'm going to unsquare both sides. A is equal to, I know that 128 is 2 times 64, and 64 is 8 squared. So that is going to be 8 times the square root of 2 over 3. So that is the value of a. That's what I have. We're not looking for the value of a. We're looking for the value of b. All right, so now that I have this, I'm going to erase it so that I have room to see what I got. So this is going to be 8 times the square root of 2 over 3. And this is going to be 8 times the square root of 2 over 3. So I'm going to use my scale factor to solve this right here. So the small one times the scale factor of 3 over 2 is equal to the big one, right? Or the large one, not b. That's why I use the large one. That's our formula for scale factor. So the small one is 8 times the square root of 2 over 3 times 3 over 2 is equal to 8 times the square root of 2 over 3 plus c. So let's do the calculation here. 8 times 3, that's 24 times the square root of 2 over 6 is equal to 8 times the square root of 2 over 3 plus c. Well, I want to reduce this, right? Technically, you know what? Let me back up. Technically, I could just say right away the 3's cancel here. So my answer is literally, when I reduce it, 8 times the square root of 2 over 2 is equal to 8 times the square root of 2 over 3. So now I can get a common denominator when I multiply, when I bring this over. So let's do that. I'm going to subtract 8 times the square root of 2 over 3 from both sides. But I want to get a common denominator when I rewrite this. So I'm going to multiply by the opposite denominator. So 3 times this. 3 times 8 is 24 times the square root of 2 over 6. So I'm right back where I was. Minus, I multiply this by 2. 16 times the square root of 2 over 6 is equal to C. So we have the value of C. When we subtract, we get 8 times the square root of 2 over 6 is equal to C. I don't know why I wrote a 6. But we can reduce this by dividing this and this by 2. So 8 divided by 2 is 4 times the square root of 2. 6 divided by 2 is 3. And that is the value for C right there. That's the answer you're looking for. All right, so let's look at the next one. That's the last one that we needed to do. Show that 2.0425 with a repeating decimal is a rational number by writing it as a fraction of integers. So we're going to start by multiplying this by 100. So 100, this is going to be our number. 100n is equal to 204, because we got 2 decimal places here because we multiplied times 100, 0.2525, and that repeats, right? That continues to repeat. So then n is equal to, I'm going to line up our decimals, 2.0425, and that repeats. We're going to subtract these from one another. We're going to use elimination. So when we subtract here, we get 99 times n is equal to these. If we were to continue to rewrite or to write the repeating part, it would be like this. Right? So the 5s would be on top of each other, the 2s would be on top of each other, the 5s, the 2s. So because the repeating decimals line up exactly, they go away. They cancel each other out. So the only subtraction we have to do is right here. So 5 minus 4 is 1, 2 minus 0 is 2, 4 minus 2 is 2, and then that would be 202.21, right? So we know when we have a number times a variable, we divide both sides by that number. N is equal to, we don't want to have a decimal over a fraction. So we're going to take the number of decimal places we have, which is 2, and multiply that by 100. 2 zeros, 2 decimal places, 2 zeros. So what that does is that it's going to be 100 over 100. So because that's 1, we can change the value of the fraction because we're multiplying it times 1. 100 over 100 is the same as the value of 1. So we are going to write 20221 over 9900. And that is our answer. And the way you check the answer is if you could take your calculator and put in this number on the top in the numerator, 20221, and divide it by the denominator of 9900, and you come right back to this decimal, which we have 2.0425252525, it just repeats, then you know that the answer is correct. We just expressed this decimal as a fraction, which was our goal. All right, that was all for lesson 116. I'll send you another video for 118.